All right, this is chapter 14 on fossil fuels, and we're going to be starting with just the basics of petroleum. So, fossil fuels are hydrocarbons, go back, from organic matter, mostly from ocean animals, very like small, like algae and diatom, kind of almost microscopic organic matter. It doesn't come from dinosaurs, like I think I was told when I was a kid. And they are considered non-renewable, meaning that while yes, more ocean critters can die and bury and be turned into oil, that's going to take a lot longer than we have, especially at the rate that we're using them. And here's just a list of oil, natural gas, coal, oil shales, and oil sands, all considered fossil fuels. And then here is our energy consumption in the US up to 2021 and the different sources. So you can see the decrease in coal, and a slight increase in renewable energy sources. Uh, Also, an increase in petroleum and natural gas, and the start of nuclear at about 1970. So petroleum is kind of a catch-all term. It includes both oil and natural gas, oil being the more solid or liquid form, and natural gas is the gas form, with an example of methane. So to make oil and gas, it's like I mentioned, all the dead ocean critters. So a lot of these tiny little critters, and they live in the ocean and they're swimming around. When they die, they fall to the bottom of the ocean. And we call that a pelagic ooze, and it's very carbon rich. And so over time, that gets buried either by other organic material or maybe some sediments in there as well. And it gets buried to a depth and pressure in that it's kind of cooked, and it changes from this kind of like dead animal carbon to a gas or an oil carbon. We call that cracking. And I think I have that on the next slide. Yeah. And so here's just a diagram showing depth and pressure and temperature. Oh, they all kind of go together. The deeper you go, the more pressure and the more temperature you get. And then here's the oil cracking window at about this depth and temperature. And then it goes a little bit deeper and it kind of cooks into natural gas. Up here, this is just kind of like your biogenic gas, kind of like a biogas. Um, okay, some natural gases um, are derived from massive amounts of plant material. That's also true for coal. Coal comes from plant material and not dead ocean critters. Oh, yes, and rapid. It has to be buried rapidly, otherwise it's just going to decompose. And so like coal forms from pretty much from swamp areas, ancient swamps, because it has that anaerobic environment, so it's not really decomposing. And there's a lot of rapid burial with that too. It's just the amount of stuff that's falling on top, all those dead trees and everything. Storms coming in with more sediment burying things. It happens very quickly um, for swamps and coal. Let's see. Okay, so now back to the cracking. So what that is your heavier, larger hydrocarbon chains are kind of cooked into smaller molecules, and those are the lighter hydrocarbons. Um, and then you get a mix of the heavy and the lighter hydrocarbons, the oil and the gas, all within the same reservoir. And then here are some diagrams of traps and migration. So this is how it gets in the reservoir. So as it's buried and it's being cooked into oil and gas, it's a very shale-like, fine-grained, more or less impermeable layer that it's in. And then as it's buried and it turns into that lighter hydrocarbon, it can work its way through time, kind of out of that source rock or that shale, as we call it, and it finds its way into a more permeable zone. So it comes into, let's say there's a sandstone above it. So if this is where it's formed, this shale layer here, it comes up into the sandstone where it can flow really easily. And it flows, it moves up because oil floats on top of water. And you have water, the groundwater table we've been talking about. So the oil floats on top of that. And then it'll just keep floating until either something stops it or until it gets to the surface. And when it gets to the surface, that's what we call the natural oil seep. When something stops it from going up any further, we call that a trap. And that is, it has to consist of another kind of geologic layer that's impermeable that stops it from moving up anymore. And here are just some examples. We have here's an anticline where the sedimentary layers have been folded. And so it comes up into this kind of bubble. And then above that, we have an impermeable layer. So it can't keep going up this way, but it can't keep following this sandstone either because that would be going back down and it wants to float on top of the water. And in this example here, we have gas on top of the oil. That's what happens because the gas is even lighter than oil. So it's going to be above the oil in the reservoir. No, it's all within the pore spaces, so it's not like there's this big gap. That's just what's filling in the pore spaces instead of the water. So this is what it's showing that the oil is migrating from that source rock through the sandstone until it's trapped. Here's just one showing that you had a reef right here and everything else around it is less permeable. Here's a fault where it juxtaposed an impermeable above a permeable layer. And then our salt domes, we get this in the Gulf quite frequently. The salt is impermeable and it kind of creates this anticline like same thought process of, it's not going to go back down, but it comes up with this bend of the sedimentary layers as the salt came up and pushed through these other layers. It kind of bends them upwards, and then the salt is impermeable. So it comes up as if it were like an anticline, and then it gets stuck right there against that impermeable salt dome. And so that is it for petroleum basics.